Hello everyone, this is Angel Rendon from BSE 38. So today we'll be discussing about CPU packaging. So what is CPU packaging? The actual microprocessor and its associated electronic circuits are packaged in a protective outer packaging. When you look at the processor, it's the packaging you see and not the processor itself. Next, we have the integrated circuit packaging. First, we have the foundries. Foundries are the companies that produce silicon wafers, which are then converted into integrated circuits and dies. Next, we have the fabless. Fabless are independent chip design and marketing firms. They're also the ones who buy wafers from foundries. Example is NVIDIA and Qualcomm. Next, we have the OSATs. The packaging of the integrated circuits and dies is handled by the OSATs or the outsourced assembly and test companies. Next, we have the IDM. A semiconductor corporation that develops, produces, and sells integrated circuits is known as integrated device manufacturer. For example, we have the Intel. Difference between the SIP and SOP, system in package. A system in package or a system in package is a number of integrated circuits enclosed in one or more chip carrier packages that may be stacked using package and package. The SIP performs all the most of the function of an electronic system and is typically used inside a mobile phone, digital music, etc. Next, we have the system on package. A system on package, or the SOP, is an emerging microelectronic technology that places an entire system in a single chip-size package. Where systems used to be bulky boxes housing hundreds of components, SOP saves interconnection time and heat generation by keep a full system with computing, communications, and consumer functions all in single chip. Next, we have the functions of each packaging. We have the foundries, fabless, OSATs, and IDM. For this, we have concluded that IDM can do all the process like designing, manufacturing, packaging, and the customer service. Next, we have the traditional packaging technology. There are two types. First, we have the pin through hole, the through hole technology. Through-hole technology refers to the mounting scheme used for electronic components that involves the use of lids on the components that are inserted into holes, drilled in printed circuit boards with a PCB, and soldered to pads on the opposite side either by manual assembly or the hand placement or by the use of automated insertion mount machines. Next, we have the surface mount technology. Surface mount technology, or the SMT, is a method in which the electrical components are mounted directly onto the surface of the printed circuit board, the PCB. An electrical component mounted in this manner is referred to as surface mount device, or the SMD. There are two types of through-hole. First is the SIP, or the single inline package. Components have a flat body oriented vertically to the printed wiring board, and a single row of pins or leads. Most small form SIPs are parallel array devices of common volume components. Next, we have the dual inline package, or the DIP. In the microelectronics, a dual inline package or dual inline pin package is an electronic component package with a rectangular housing and two parallel rows of electrical connecting pins. The package may be through-hole mounted to the printed circuit board or inserted in a socket. Next, we have the types of SMT. First is the quad-flood package. A quad-flood package is a surface-mounted integrated circuit package with a gull wing leads extending from each of the four sides. Next, we have the pin grid. It is a type of integrated circuit packaging. The package is square or rectangular and the pins are arranged in a regular array on the underside of the package. The last, we have the ball pin. It is a type of surface mount packaging used for integrated circuits. The BGA packages are used to permanently mount devices such as microprocessors. Next, we have the silicon interposer. An interposer can be defined as a silicon that can be used as a bridge or conduit allows electrical signals to pass through it and onto another element. Interposers are normally very frequently used in multi-die chips or boards. Its job is to either spread the signal to a wider pitch or take the connection to a different socket in the board. There are two types. The first is the passive silicon. With a passive silicon, all routers contribute to the chiplet area and are implemented in the 11 nanometer process technology. Second is the active silicon interposer. With this, the routers are placed in the interposer, increasing the interposer active area used to yield calculation but reducing the chiplet area. Next, we have the structure. First is the TSV or the True Silicon Via. A True Silicon Via or the True Chip Via is a vertical electrical component or connection that passes completely through a silicon wafer or die. Next, we have the RGL or the distribution layer. It is an extra metal layer on a chip that makes the I or the 10 pads or IO pads of an integrated circuit available in other location of the chip for better access to the pads where necessary. The last we have the under bump metallization. It is an advanced packaging process that involves creating a thin film metal layer stuck between the integrated circuit or copper pillars and solder bumps in a flip chip package. Next we have the 2.5D and the 3.5D. 2.5 packaging. There is no stacking of dice on dice, but dice are in silicon interposer. The dice are packaged into single packaging, or the package in a single plan, and both are flip chip on a single silicon interposer. Next, we have the 3D packaging. Interposer and dice are stacked one above another. Dice interact among each other with TSVs. TSV is a high-performance interconnect made of a pillar-like structure with copper, tungsten, or poly through silicon that provides electrical interconnects through a silicon die or through wafer. Next, we have the packaging manufacturing process. First is the interconnection. Under it, we have the wire bond. Wire bonding is the method of making interconnection between an integrated circuit or other semiconductor device and its packaging during semiconductor device fabrication. Next, we have the flip chip, a computer chip that is installed on a circuit board face down with connection formed by solder bumps rather than wires. Next, we have the interposer. The purpose of interposer is to spread the connection to a wider pitch or to reroute a connection to a different connection. Next, we have the process test or the test process. Next, we have the in-process test, which includes wire pull test and die shear test. While for the post-process test, we have the temperature cycling, X-ray inspection, scanning acoustic, microscopy, and electrical test. Next, we have the wafer level packaging. Wafer packaging is the technology of packaging an integrated circuit while still part of the wafer. Um, in contrast to the more conventional method of slicing the wafer into individual circuits and then packaging them. It has two types. First is the fan-in, refers to the technology of packaging an integrated circuit at the wafer level instead of the traditional process of assembling individual dies into packages after dicing them from a wafer. Next, we have the fan out or the FO. It is an integrated circuit package technology and an enhanced of standard wafer level packaging solution. Last is we have the panel level packaging. Panel-level packaging technology is used to package a field programmable gate array, CPU or GPU, and power control IC module, as well as baseband, Wi-Fi devices, RF devices, transducers, and networking and service. That will be all. Thank you.